Just recently, our Sun unleashed a supermassive solar flare, and it was the most intense one in 7 years. Solar flares are powerful explosions happening within the Sun's atmosphere, intense bursts of radiation rising from the surface of our star. How dangerous are they for us? Let's figure it out. Solar flares can indeed affect life on Earth, disrupting everything from power grids to GPS. They can have an impact on spacecraft and astronauts. They produce auroras, painting the sky with vibrant colors near our planet's poles, which is actually not a drawback but a very beautiful view. The most recent flare, part of a series of flares, was classified as an X6.3 event. This classification is based on the X-ray brightness of solar flares. There are 5 classes of solar flares, with A being the weakest and X the most powerful. Each class also has 9 subdivisions, from 1 to 9. The flare in question wasn't as monumental as the flares of September 2017. Those included an X9.3 and an X8.2. And still, it was an awe-inspiring display of energy. The flare stood out as the largest of its kind during the current solar cycle. A solar cycle is a period during which the Sun's magnetic field undergoes a complete reversal. One cycle usually lasts for about 11 years. At the moment, we're in cycle 25. It started in 2019 and is likely to last till 2030. The progression of the cycle has an impact on the star's activity levels. The Sun is quite tranquil when the activity is minimal, and at solar maximum, this activity reaches its peak. During this period, we can observe lots of solar flares and sunspots, areas where the magnetic field is around 2,500 times stronger than that on Earth and higher than anywhere else on the Sun. The particles ejected by solar flares take roughly 2 days to reach our planet. They often ignite auroras. During the most extreme solar events, these auroras can be seen not only close to the poles but also further away. Solar flares and related coronal mass ejections can pose a threat to our world that heavily depends on technology. The problem is that high-speed solar winds emanate from coronal holes. Those are openings in the Sun's magnetic field where streams of solar winds rush out of the atmosphere of our star. The plasma in these regions, with coronal holes, is cooler and denser than in other parts of the Sun's corona. Insanely fast, solar winds can worsen the situation, impacting our technology and leading to greater disruptions on Earth. You've probably seen headlines like, "Solar storms of 2025, Earth's doomsday is coming." They cause anxiety and panic. Totally unnecessary. It's true that the Sun is entering a period of increased activity, which will culminate in July 2025. But these claims about doomsdays, apocalypses, and absolute destruction are not based on scientific facts. Solar storms are just a natural phenomenon, and while they do affect our planet, experts don't expect any catastrophic events to occur even in 2025. Our power grids, communications, and GPS navigation may end up somewhat disrupted. However, the severity of the situation will depend on the direction and strength of the storm. That's what you need to know about the upcoming events. Since solar cycle 25 will most likely peak during that period, there will be more chance of observing solar flares and coronal mass ejections, CMEs. Earth might witness disruptions at different levels. Solar flares will likely interfere with radio communications and GPS navigation. And CMEs, which impact Earth's magnetic field, may trigger geomagnetic storms, potentially leading to power outages and satellite damage. We should be aware of the potential consequences of these cosmic events and take precautions like having backup power sources. But it's crucial to avoid panic. NASA and NOAA, National Oceanic and Atmospheric Administration, regularly provide updates on space weather. They actively monitor the Sun, and you can stay informed through reliable sources.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it produced a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England Highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the sun. A protostar is a young star that's still gathering its mass, and that's exactly what the sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the sun takes 153 hours, because it's pretty far away from the sun. After several hours without sleep, we get tired, and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches. So it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us.
Ah, beautiful! You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh? Hey, look at that! Your friend pulls his head up out of his phone. You shouldn't look directly into the... Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun's halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals flying around 20,000 feet. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage. So, not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts about 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many ways. J-shaped trees means there's a landslide coming. Since the ground is moving slowly, the trees grow into the super selfiable shape. Try to find a flat area and avoid going near any trees, unless you have superhuman strength. You're on a nice walk on the beach. Sand, sun, not a cloud in the sky. Then, out of nowhere, you see the ocean going back away from the shore. Suddenly, you can even see bits of coral, small fish, and other random small sea animals. That's a good sign to leave. There might be a tsunami on the way. A tsunami is formed when there's an earthquake underwater, and it can hit the coast at 500 miles per hour. It's mostly a Pacific Ocean thing, but why risk it? If there's a channel of choppy water on the beach, stay away. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange gap in the waves, or you might notice random bits of seaweed going in all different directions. If you don't ever find yourself caught in a rip current, try to stay afloat and don't waste your energy swimming against the current. Yell out for help and try to float your way along the beach. Once you break out of the channel, swim diagonally to the shore. If you find yourself in the ocean and see a group of sharks swimming, okay, this scenario doesn't sound good either way. Well, the good news is they're not necessarily coming for you. The bad news? The sharks might be trying to escape from a huge tropical storm or even a hurricane. Sharks can sense these things, so when nature gets angry, they group together and swim deep under the surface to get to safety. You probably shouldn't follow them. Good luck! The golden rule since ancient times: follow the animals. Insects, rats, and snakes leave their homes a couple of days before really big earthquakes. Scientists can't track or really explain how they know it's coming. It seems animals really can sense earthquakes, maybe because they feel those smaller initial shock waves that we don't even notice. What if you see animals running towards you? Well, that could mean you're about to get eaten for breakfast. Or it means there's a wildfire behind them. Amphibians like frogs, toads, and salamanders try to protect themselves by burrowing down into the ground. Others just run. Before you start running alongside them, check to see if you can see smoke. You don't want to sprint flat out for nothing. Well, it's not just animals. We can spot warning signs too. For example, if you notice your hair suddenly starts to stand on end and your jewelry starts to buzz, take shelter right away. Lightning might be about to strike somewhere nearby. If you're outside and can't run into a house, make sure not to stand near any tall structures. Lie flat on the ground. Be near water. Seek shelter under an isolated tree or stand in an open space. And don't stand on top of the Empire State Building. That thing gets zapped hundreds of times a year. Do you like skiing? It's all fun and games until all you can see is white. Avalanches can move up to 80 miles an hour, so watch for some warning signs. Does it feel hollow when you walk in the snow? Are there cracks around your feet? Can you see a huge avalanche coming? Time to go! Sometimes a storm mixes its blue light with the red light from the sun, and you get a pretty impressive green. Enjoy it from a safe distance, preferably indoors. This super tall thundercloud usually means you're about to get smashed by hail, or worse, a tornado. Find cover somewhere, like in an underground parking lot or a basement. It might be a bit embarrassing if you're wrong, though. Okay, we know volcanoes can be dangerous, but the lakes near them? Is anything not a sign of danger? Lakes that are near something boiling hot that never cools, so volcanoes, are like wildly shaken soda cans, just about to burst. The magma that's underground actually pushes carbon dioxide into the bottom of the lake, and that gas stays there, waiting. Then, even something boring like rain can disturb the lake a little too much and bam! Or boom! You get the picture. Diving, swimming, snorkeling, the sea can be amazing, but it's pretty unpredictable. When two wave currents run into each other, they can create a cross sea. It looks pretty cool from far away, but it can be really dangerous for swimmers, surfers, or even ships. There's a strong current roaming around under the surface. You're walking on the beach, apparently every good story starts like this, and all of a sudden, ooh, a cave. How cool is this? You should probably go in there, explore a bit, and no. If there's a full moon out, you might not be able to get out of that cave. A full moon affects the tide and makes it lower than usual. That cave might be more accessible, but instead of an exciting adventure, you could end up trapped in there until the next full moon. Bring a big lunch. A wall cloud is one of those things you're both excited and scared to see. Scared because you don't know what it is. Excited because, well, how often do you see something like that? Whatever you feel, tell your legs to start running. During a thunderstorm, these wall clouds sit lower than anything else and can be up to 5 miles long. And if they start spinning, well, Dorothy ended up in Oz. Who knows where you'll end up? It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Ooh, creepy. Oh, ocean, come on, not you again. Okay, but just one more. If you see the oceans turned all reddish-brown, don't go in the water or anywhere near it. This red tide is caused by toxic algae and is something you can find all over the world. That toxic algae can be there even if the ocean's a normal color. Getting that stuff all over you can cause some health issues. Rinse yourself off in fresh water as fast as you can. You know, they even wrote a holiday song about it. Algae Home for Christmas. No, really. Tidal locking is when a moon or a planet always shows the same face to another celestial body. I know I do. The moon, for instance, always shows one side to Earth. It doesn't matter if you use binoculars or a telescope, you'll see the same craters and plains every time. This happens with many big moons in space. Take Jupiter's moon, Io, or Saturn's moon, Enceladus. Even Mercury, which rotates 3 times around its axis for every 2 leaps around the Sun, is almost tidally locked to our star. Now here on our planet, the moon's pull creates tides on Earth, making the water rise about a foot. This pull also stretches the moon, making it slightly football-shaped. Many years ago, the moon spun way faster than it does today. This made its protruding parts shift constantly, like the Earth's tides. But the moon's bulges didn't align with Earth's pull. Soon enough, the Earth's gravity pulled them in closer, slowing the moon's spin until it stopped. But if we look at the grand scheme of things, we'll see that our planet isn't tidally locked to the Sun. Earth rotates on its axis, completing one rotation roughly every 24 hours, while orbiting its star. This rotation creates day and night. Lots of things prevent our planet from constantly showing the same face to the Sun. First, Earth's rotation rate isn't perfectly synchronized with its orbit around the star. The presence of the Moon also plays a crucial role. Our satellite's gravitational pull creates tides on Earth, which slightly slows down Earth's rotation over time and balances things out. There's also quite an impressive distance between the Sun and the Earth, 93 million miles. So even if the Sun's gravitational force is intense, it's far enough away to prevent tidal locking. Now, what if space travel gets advanced enough that we end up visiting such a tidally locked planet, one that is constantly trapped between 2 extremes, eternal darkness and constant sunshine? We can gather some data by figuring out what would happen if the Earth suddenly stopped spinning on its axis. Bad news is, the consequences would be devastating. Right now, we're all moving along with Earth's rotation, even if we don't feel it. If the planet stopped, everything on its surface would be launched eastward. People, buildings, and natural features hurtling sideways at high speeds. Afterward, the remaining high-speed winds, still rotating nearly as fast as the planet, would damage its surface, acting as a cosmic nail file. Even if the slowdown happened gradually, the effects would still be dramatic. The first noticeable change would be the Sun's motion across the sky. Without Earth's rotation, a day would last a half a year. This disruption would throw off our biological rhythms, affecting sleep dynamics and daily activities for many species. Earth's rotation also influences atmospheric patterns, which affect the weather and climate. Air currents would change too, leading to extreme events like desertification or the melting of polar ice caps. Hurricanes, reliant on Earth's rotation to form, would cease to exist. A motionless Earth would likely translate to the loss of our magnetic field, which shields us from harmful cosmic rays and solar storms. Boy, we in trouble now, huh? In the same thought experiment, let's say oceans won't freeze where it's cold or evaporate where it's hot. Because of its spin, there's a centrifugal force that has made our planet a bit wider around its middle. If we measure the Earth around the equator, it's about 13 miles wider than if we measure it from pole to pole. This widening of the solid Earth happened very slowly over billions of years. But the liquid water in the oceans would move more easily. Because of the spin, the water around the equator is about 5 miles higher than it would be on a still planet. If the Earth stopped spinning, the oceans would start moving towards the poles. At first, only some areas around the equator would become land. But eventually, a big continent would form in the middle, like a belt. You could walk around the Earth at the equator without getting wet, even though it would be really cold on one side and really hot on the other. The water that might move away from the equator would end up at the poles. There would be 2 separate oceans around each of these points, with no connection to the equatorial continent. In the north, Canada, Greenland, Asia, and Europe would all be underwater, following a line similar to the border between the US and Canada. But countries like Spain, for instance, would mostly stay above water. Despite these extremes, some say life could still exist in the twilight zone between light and dark. If we could draw it, it would be this softly illuminated region, looking like it's always on the brink of a sunset. This in-between domain could potentially offer the ideal conditions for life, with temperatures balanced between extremes. The planet would end up resembling an eye. Its sunward-facing hemisphere would look like a parched pupil, encircled by a blue-green iris, the place with lots of water and vegetation. Now, it's not all that grim. Since there's liquid water on our planet's surface, sunlight could turn it into clouds that could help us control the temperature should it stop spinning. Also, the way heat moves around in the air could make the climate nicer overall. Winds could carry warmth from the sunny side to the dark side, similar to how ocean currents warm up Europe and cool down Africa. Plus, the way gases move in the air might stop a planet from getting stuck facing one way all the time. Venus, for instance, should be locked in place facing the sun, but its atmosphere helps keep it turning. Our planet might end up pulling a similar trick. Rainfall on a tidally locked planet could further regulate temperatures, especially if there's enough land. On Earth, rain interacts with rocks, trapping carbon and cooling the atmosphere. This process could also help manage carbon dioxide levels. If we were to prepare for a tidally locked world, the Sahara Desert would be a good place to start the boot camp. Located in North Africa, it is the biggest hot desert globally. It covers a vast area from the Atlantic Ocean to the Red Sea and from the Mediterranean Sea to the Sahel region. During the day, the temperatures get really hot, up to 122 degrees Fahrenheit, and at night, it can get as cold as 41 degrees. That is a wide swing. You might stumble upon a sandstorm here and there, but rain is very rare. When it does happen, though, it's intense and can cause flash floods, making the area dangerous. Despite the tough conditions, some animals manage to survive here. One such creature is the Kenneck fox, which is the smallest fox to exist on our planet. It has big ears that help it handle the heat, and its environment stretches from Morocco to Egypt, and even down south to northern Niger and east to Kuwait. It eats whatever birds, insects, and rodents it can find in the sand. As for the coldest place on Earth, data suggests it's located in the eastern Antarctic Plateau. Research indicates that the air temperature there can drop to minus 137 degrees Fahrenheit. Now, if we need to find animals that have adapted well to living in refrigerator with built-in ice maker-like conditions, we just need to look at the emperor penguins. They gather in tight groups, sometimes with huge numbers of these birds, to keep warm. They can't stay in these huddles for too long, though, because they get too hot. Scientists found out in 2015 that it can get as hot as 100 degrees Fahrenheit in the middle of the penguin mosh pit. These birds are the only animals that produce offspring during the Antarctic winter. They travel quite far, somewhere around 50 to 100 miles, to lay just one egg. While the dad keeps the egg warm for about 2 months, mom goes back to the edge of the ice to find food. It's a routine that usually works well, as long as the weather is consistent. The first trip intending to land on the moon made by human mammals took 3 days, 3 hours, and 49 minutes. The Apollo 11 astronauts needed to travel some 240,000 miles to get there. Their plan was to touch down on a place on the moon called the Sea of Tranquility because it had good visibility and the terrain there was pretty smooth. Well, up until the last few moments of the flight, when all these big craters appeared that they had to avoid, they finally landed with just 30 seconds of fuel left. Ooh, that's called cutting it close. Hey, how would you like to land in your jetliner with only 30 seconds of fuel left? So, now you know. Later that day, July 20th, 1969, Neil Armstrong stepped onto the lunar soil, saying, "That's one small step for a man, one giant leap for mankind." The astronauts were planning to sleep before the first moonwalk, but they chose to go outside earlier than scheduled. They obviously couldn't sleep. I mean, could you? Since that first visit, our lunar satellite has accumulated quite a collection of memorabilia from Earth. Let's look at some of the most important and weird stuff that humans have left on the moon. Take footprints, for starters. I know they're not technically objects, but the marks left by Neil Armstrong and Buzz Aldrin do show that humans have been there, just in case someone or something else drops by. Since the moon doesn't have any wind or rain, the footprints should still be relatively untouched. NASA put in a lot of effort to make sure these footprints stay protected, as well as the location of the initial moon landing. Rules were set into place for future missions to make sure they wouldn't alter the initial site, as it's an important piece of history, kind of like a national park that you can't get to. Now, astronaut Charles Duke wanted to leave a photo of his family on the surface of the moon. If that didn't make him the best dad ever, I don't know what would. He did take his family to the moon, right? On the back of the picture, he wrote that he had come from Earth. He also added the date when he landed on the moon, which was April 20th, 1972. Now, there's a good chance that his family is no longer visible in the picture today. Because of the exposure to strong solar radiation, the colors in the photo have likely faded away by now. To this day, Charles Duke remains the youngest person to visit our moon. He was 36 years old at the time of his mission. Now, there are many flags on the surface of the moon too, but the flags left there must have had a similar fate to Duke's photo. They're most likely discolored by now. During each lunar landing, a flag was planted as a tradition started by Apollo 11. This tradition continued with all future Apollo missions. The flags were made using metal poles to stretch the flag out so they could be seen on the moon. But since there's no wind, they never move. Back in the 1600s, astronomer Galileo Galilei dropped two objects of different weights from the Leaning Tower of Pisa to show that the speed of the fall would be the same. In 1971, astronaut David Scott repeated the experiment on the moon and proved Galileo's theory correct. He dropped a feather and a hammer at the same time, and as predicted, they both landed on the moon's surface simultaneously. Fun fact, the feather came from the Air Force Academy's Falcon mascot named Baffin, with its permission, of course. These objects were both left on the lunar surface. Now, what about art pieces on the moon? We've left some of those out there as well. The Fallen Astronaut sculpture was made by a Belgian artist and left behind by the astronauts of the Apollo 15 mission. It was a small statue requested by David Scott, the head of the mission. Scott said the statue was to memorialize the astronauts and cosmonauts who gave their lives for the advancement of space exploration. Meanwhile, astronaut Alan Shepard even played some golf on the moon during his mission on Apollo 14. He brought a golf club head, yes, he got permission first, and attached it to a tool. Then he tried to hit two golf balls. Hey, it's hard to do in a clunky spacesuit. He did better on the second one. It's safe to say that he didn't bring the golf balls back, and they should still be there on the moon. There's yet a message from Queen Elizabeth II there. The monarch prepared a message which accompanied Neil and Buzz to Tranquility Base during the Apollo 11 mission. It was written on a tiny disc the size of a coin and also featured messages from over 70 other leaders from all over the world. I'll bet the printing was really small. Her message said she was proud of the astronauts and their accomplishments and hoped their journey would benefit all of humanity. The disc was then placed where Armstrong and his team first landed on the moon. After they returned, they met the Queen at Buckingham Palace. Their encounter was memorable too. Neil Armstrong almost couldn't speak to the Queen at all because he had a cold. Another astronaut named Mike Collins was so nervous about the protocol, he almost fell down the stairs. Now, some objects that exist today on the moon weren't left there on purpose. One of the most interesting moments of the Apollo 11 mission was when Neil and Buzz were getting ready to go back to Earth. They had to chuck everything they didn't need so they wouldn't be weighed down at liftoff. They also needed to store all the rock samples they had gathered from the lunar surface. This created a toss zone that archaeologists could potentially study one day. Waste like this acts as a timeline for Earth's history, but it can also help us understand what happens to objects that spend a lot of time on the surface of the moon. Now, most astronauts became pretty sentimental when strolling on the lunar dust, and who could blame them? They were thousands of miles away from their families. So that's why, in 1972, NASA astronaut Eugene Cernan wrote his daughter's initials, TDC, in the dust on the moon, and gave a speech before leaving. He said, "We leave as we came, and hopefully will return with peace and hope for all." Unfortunately, this marked the end of the Apollo lunar missions. Technically, his daughter's initials should still be there on the surface of the moon, just like all the astronauts' footprints. Can you believe it's been more than 50 years since people started exploring the moon? No worries though, as NASA's been preparing for future lunar explorations for quite some time. This new mission is called Artemis, and it aims to build some sort of settlement out there. This way, the moon can be studied in safe conditions for longer periods of time. For starters, NASA launched Orion, a spacecraft without a crew on board, to orbit the moon and come back to Earth. This was a test drive. Before NASA transports people to the moon again using newer technology, all safety measures need to be worked out and confirmed. But one day soon, Orion is going to take astronauts back to the moon. One cool thing about this spacecraft is that it comes with a launch abort system, which is meant to keep astronauts safe in case something goes bad during the launch. It also features a special service module, which is like a battery that fuels and propels Orion through space. It also supplies astronauts with water, oxygen, and power, and provides temperature control. But Artemis also looks to build a long-term human settlement on our satellite somewhere around the 2030s. However, searching for a cozy place on the moon isn't as easy as you'd think. Thankfully, NASA specialists produced an ingenious idea. They found some lava tubes on the surface of the moon, and they have pretty steady temperatures inside. The main problem with the first moon landing back in 1969 was extreme temperature fluctuations. So these caves might be the perfect solution. Not only is the temperature in there suitable for humans, but they could also help shield astronauts from cosmic rays, solar radiation, and meteorites. It's also good news that we have similar structures here on Earth. Before we get back to space, we can study them to better understand those found on the moon. Here on Earth, these holes form once the top of a stream of lava solidifies, and the molten rock inside drains away, creating this tube. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves. And by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass.
Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too? You step on the surface of the moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours. Jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the moon. But that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermoquakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo seismic network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the moon and Earth aren't the only places where earthquakes occur. No, scientists of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namazu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs. So tonight, go out and look at the moon through a telescope, and you'll see many craters. No one still knows how they appeared there. Some of them have formed recently. Scientists have discovered a double crater on the moon that appeared for a strange reason. In March, a rocket crashed into the moon, and no one knows who owned it and why it left such a trail. If a regular rocket had fallen there, it would have left one hole. A standard space rocket has a heavy engine on one side and a lighter fuel tank on the other. But this time, there had to be 2 heavy sides on one rocket to leave a double crater. That's strange. No one knows what it is, and no one has claimed to be the owner. It was probably part of a large 3-ton rocket. This piece had been flying in space for several years. At first, astronomers thought it belonged to SpaceX, but the company denied this claim. Also, they thought that China had launched the rocket, but this was also wrong. In the near future, NASA experts hope to find out the truth. The problem with tracking such rockets and space debris is that this is quite expensive. Companies don't want to spend too much money on it. But soon, this will change. People will have to spend billions of dollars to monitor garbage or destroy it, since it's getting too crowded in space. Space companies will have to solve this problem, as it poses a serious danger to satellites and spacecraft. Just take a look. There are millions of pieces of satellites and rockets flying in space. Some of them are the size of a basketball, others are as tiny as a raindrop. The total weight of all this debris is about 9,000 tons. This is almost 2,000 tons heavier than the Eiffel Tower. Okay, all this garbage is floating there, so what? The problem is that it's not just floating, it's moving at a speed of 17,500 miles per hour. A tennis ball will fall apart into several pieces at such a speed on the surface of our planet because of air resistance. But there's no air in space. Nothing prevents a tiny piece of metal from reaching a speed 20 times faster than the speed of sound. A piece of paint at this speed can easily damage the casing of a spaceship. Once, several shuttle portholes were replaced because of the damage caused by flying chunks of paint. Now imagine what a piece of metal the size of a basketball can do to a spaceship. It could bring down the International Space Station. Many satellites were destroyed by space debris that crashed into them, and when those satellites exploded, they burst into thousands of small parts, which also turned into dangerous flying objects. For example, in 1996, a fragment of a rocket damaged 10 years earlier crashed into a French satellite. In 2009, a failed spacecraft destroyed another commercial ship. As a result of the collision, about 2,300 tracked fragments appeared, as well as lots of tiny untracked ones. Today, satellite operators receive warnings about potential collisions with space debris, but these messages are often either inaccurate or reach the operators too late. Imagine that a screw is flying at great speed toward your satellite. You'll hardly have time to dodge it. Perhaps it won't hit your satellite at all. This uncertainty makes these warning sensors useless. The problem becomes much more serious when it concerns the ISS crew members. A durable spacesuit can't guarantee protection from flying debris, and the station itself is too large to save itself from big objects by dodging. To keep astronauts safe, scientists have a catalog of things that are the size of softballs or bigger. They monitor thousands of fragments and analyze their trajectories, material, and dimensions. Next, they use the pizza box method to dodge garbage. This is the unofficial name for an imaginary square that is used to calculate the risks of a collision with space debris. So imagine a giant pizza box. It is 2.5 miles deep, 30 miles wide, and 30 miles long. Now put the entire International Space Station in this box. Yeah, okay, you can have it with pepperoni. Anyway, if some space object is heading toward the edge of the box, the crew will begin to develop a plan of action. The box's radius is quite large compared to the station, since it's difficult to calculate the debris' trajectory. If there's a chance that something might approach the box, then it can also damage the station. When operators receive a signal about approaching debris, they analyze it. Depending on the data received, the crew begins to act in a certain way. If it's something small and heading for some part of the ISS, the astronauts should evacuate from this part, and after that, they'll do repairs there. If something big is approaching, the entire station can perform an evasive maneuver with the help of the engines or a docked spacecraft. One such trick required about 5 hours of hard work. The station is a big, clumsy ship, so it's important to know about the threat in advance. From 1999 to 2020, the ISS made 29 maneuvers to avoid collisions. 3 of them occurred in 2020, and there will be more since the amount of garbage increases. If some object is too big and fast and can damage critical components, and it's impossible to dodge, the entire crew will have to evacuate. In the future, NASA and other space agencies will have to think about how to destroy this debris or remove it from orbit. One option is catching everything with extensive space nets. One agency suggested developing a solar sail that clings to debris and propels it to a low orbit. Another wanted to use an electrodynamic cable to slow down the speed of space debris with the current. This maneuver will cause space garbage to move toward the surface of Earth and burn up in the atmosphere. But what if one of these pieces still reaches the ground? Even now, many satellite parts fall on Earth. Fortunately, this is not so dangerous. The probability of cosmic garbage falling on your house is minimal. In addition, 70% of our planet is covered with water. Of the remaining 30%, only 3 to 10% are occupied by people. Almost all space debris falls into the ocean or unpopulated parts of dry land. But let's say some part of a satellite damages your property. In that case, the company that owns this space object will cover the losses. Such cases are rare and occur because of accidents in orbit. But sometimes, companies intentionally abandon their satellites. If a spacecraft is out of order, they turn it off and use the remaining fuel to slow it out of orbit and drop it in a safe place. Almost all such objects fall in the region of the spacecraft cemetery. It's located at the most remote point on Earth, Point Nemo. It's in the southern Pacific Ocean, east of New Zealand. The nearest island is more than 1,000 miles away. The distance to the International Space Station is much smaller. It's challenging to get to this place since no ships travel there. That's why most satellites end up in that area. It looks like an endless sea. The ocean there absorbs explosive waves of any power without consequences. Even if some fallen ship or rocket causes a giant wave, it dissipates long before it reaches dry land. Fish and other marine creatures are also not at risk. Point Nemo is one of the least inhabited areas on Earth. Underwater currents carry nutrients through the ocean, and tiny living creatures such as phytoplankton and other organisms feed on them. But these currents don't reach Point Nemo. Another way to deliver nutrients in the ocean is wind, but there's almost no wind at Point Nemo. This place doesn't have enough food to let large life forms develop. Just imagine how lonely and silent it is there. Sometimes a broken rocket breaks this silence, crashing into the water at great speed and descending to the seabed, where thousands of other satellites are waiting to welcome it. Back when Apollo missions were launched, astronauts returning from the moon claimed that moon dust, the gray sand-like dust covering much of the satellite surface, smelled and tasted, yes, they actually tasted it, like gunpowder. What the stuff moon dust is made of is nothing like gunpowder. About half of its composition is silicon dioxide glass from impacts with meteorites. They hit the surface of the moon at incredible speeds. Whoa! The high temperature makes the topsoil fuse into glass, and the impact shatters it right afterwards, creating the gray and clingy dust. The rest of moon dust ingredients are minerals such as iron, calcium, and magnesium, while old-fashioned gunpowder consists mainly of saltpeter, charcoal, and sulfur. In other words, moon dust shouldn't smell like gunpowder, but it does. Besides, when astronauts brought samples of it back to Earth, there was no smell left at all. One explanation could be that the moon is similar, in a way, to Earth's sand deserts, like the Sahara. It's extremely dry and arid. When you sniff the air in a desert, you don't smell anything. But if you get caught in the rain there, the moisture will raise all kinds of odors from the ground that were previously trapped in the dry sand. With moon dust, it might be similar. While on the surface of the moon, it doesn't smell at all. Not that the astronauts could sniff at it wearing their spacesuits, though. But when brought back inside the landing module, the dust came into contact with moisture in the air and started emitting its strange odor. Another reason for this could be a reaction of moon dust to the solar wind. Ionized particles from the sun hit the bare surface of the moon and stay there. There's no thick atmosphere to protect it from those ions, so they travel freely right to the ground. They're very lightweight, so they can fly off and sort of evaporate from the slightest of nudges. And when astronauts took the moon dust samples to the landing module, those particles could have started moving around and giving off the specific smell. This might also explain why the samples didn't keep their odor when brought back to Earth. Since the particles are so light, they might have flown off the samples already in the landing module. And when they were placed in airtight containers, there were little or no ions left on them. Another explanation is that those airtight containers weren't so airtight after all. Moon dust is basically very small crystals with extremely sharp edges. They unexpectedly made tiny cuts in the seals, letting in air and moisture, and so the ionized particles leaked out of the containers. Scientists believe they should study moon dust on the surface of the moon itself to find out everything about its properties. Now, there are hundreds of thousands of craters on the surface of the moon made by falling asteroids, but one of them drew a lot of attention. It turned out to not be just an impact crater, but a tube, looking most like an entrance to a cave system. Scientists found a specific echo pattern that suggested there was a hollow area beneath. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field. Researchers believe there could be an entire geological wonderland under the surface. It could be a good shelter for astronauts landing on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. Wide range of temperatures, low atmosphere, no magnetic field would protect life on the surface from things like radiation or solar wind. Astronauts wear spacesuits. They can't protect them over long periods of time, but a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, and that's how an empty tube appears. Our planet also has lava tubes, but they're not as big as the one found on the moon. Back in 1178, I wasn't around then, at least 5 people in England claimed they had seen the moon split into 2 from its upper tip. It was in the shape of a crescent at the time of the event. When the crack widened, fire started blazing from it, which the single monk who chronicled it described it as a flaming torch sprang up, spewing out fire, hot coals, and sparks. Then the moon started shifting around and pulsating, but soon stopped and turned a slightly darker shade. The event didn't receive much attention from scientists, though, until the second half of the 20th century. Researchers studied the chronicle and figured out there was a huge 14-mile-wide crater on the surface of the moon at about the spot described in the book. Only a very large asteroid could have left such a scar on the satellite's face. And when they investigated it more closely, they found out it was pretty recent by astronomical standards. In fact, it really could have appeared about 800 years ago. But in that case, millions of fragments from the asteroid and the moon would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would have definitely been in the archives. But that didn't happen. In addition, many scientists argue that the crater isn't as young as it might seem. The most popular and justified theory is that it's about 1 to 10 million years old. If it had appeared as recently as 800 years ago, parts of the surface of the moon in and around the crater would still have been warm from the impact. The most likely explanation of what really happened back in 1178 is that observers were extremely lucky to see an asteroid falling towards the Earth and burning in our planet's atmosphere. The spectacle would have been incredible, and seen from a proper angle, the burst of the asteroid could have really looked like it was the moon exploding. That would explain why there were so few witnesses of the phenomenon. The right spot to see the show, as they did, was only a couple of miles wide. As for real events on the moon, water and oxygen were unexpectedly discovered on it not long ago. Water might have been brought to the satellite by asteroids hitting its surface, many of them carrying H2O molecules, and those that are left on the moon in tiny amounts after the impact. There's precious little water there, though. By comparison, even the Sahara Desert has more of it than the entire moon. Oxygen is also present as separate molecules floating around, so you still can't breathe on the moon. Solar wind brought them there. Waves of energy from the sun travel at extremely high speeds through space, scrape oxygen from the upper parts of our atmosphere, and carry it further. Eventually, the wind with the oxygen molecules reaches the moon. And that's where something incredible happens. The moon starts rusting. There's plenty of iron in the lunar soil, and when it's exposed to oxygen and water, it naturally rusts. Some parts of the moon have actually already turned slightly reddish. They're regions where there's the highest concentration of molecules. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from the corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's crescent-shaped. The flashes come and go very quickly, almost like lightning. And in fact, that's what they basically are, electric bursts. Tidal forces are to blame for this. They cause mechanical stress buildup in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. But still, there's so far been no green cheese discovered there, or moon pies for that matter. Disappointing, I know. You're wandering across the Sahara Desert, and all you can see around is endless sand. And then, all of a sudden, you spot this mark in the sand. The wisest thing to do is run away from that spot as fast as you can. Because if you squint and focus really well, you'll realize that you're looking at a Saharan horned viper hiding in the sand, waiting for its next meal. Paradoxically, the bite of the snake has never led to human fatalities. But then, why should you run away? Well, let's find out. The Saharan horned viper is one of the desert's most famous snakes and a pro at hiding in plain sight. The Cerastes cerastes, which is this snake's scientific name, is one of the most well-camouflaged creatures in the entire animal kingdom. It can measure between 12 and 24 inches in length on average, but the biggest specimens can stretch up to a whopping 33 inches, nearly 3 feet. And while that might not seem too long, trust me, you wouldn't want one to sneak up on you. Interestingly, the females of this species are larger than the males, which is rare in snakes and gives the females an even more intimidating presence. But the truly unique thing about this viper is, of course, those creepy horns, one above each eye. They give the reptile a dragon-like look, setting it apart from most other desert vipers. Not all Saharan horned vipers have these horns. Some have small nubs or none at all. You could say it's a bit of a genetic lottery. Still, these horns add to the viper's threatening vibe and make it look even more fearsome. But it's not just their horns or size that makes them fascinating. Males and females look different beyond just their size. Males have noticeably larger heads and eyes than females. And compared to their relative, Saharan horned vipers have bigger heads and are more likely to sport these spooky horns. Now, let's talk about what makes the Saharan horned viper a true master of survival: its uncanny ability to blend into the sands. This viper's coloration matches the Sahara's various shades: yellow, pale gray, pinkish, reddish, or light brown. It has an intricate pattern along its back, with dark, semi-rectangular patches that sometimes fuse into crossbars. At the same time, the underbelly is white, and the tail often has a black tip. And it's another trick. Some animals can mistake this feature for a scorpion stinger. This camouflage is the viper's main line of defense and its tool for hunting. The reptile doesn't just slither around in plain view. Instead, it buries itself in the sand. The viper can wiggle its body under the soft desert sand, leaving only its eyes and nostrils visible. Imagine a creature so skilled at hiding that it can lay completely flat and practically disappear, waiting for hours until an unsuspecting mouse or lizard or human wanders by. During the day, the viper also takes shelter under rocks and in burrows left by other animals. Sometimes it even simply hides in the shade of bushes. For a creature that looks so fierce, the Saharan horned viper is surprisingly even-tempered. It won't waste its venom on a threat it can avoid, preferring instead to lie still or try to hide. But when it feels truly threatened, the snake gives a truly dramatic warning. It rubs its coils together, producing a distinctive hissing and crackling sound that lets you know it's ready to strike. And if you ignore that warning, well, this viper's bite is loaded with toxic venom that can be quite dangerous. That's why handling such snakes can be a fatal mistake, as two unlucky handlers in Europe once discovered. Both men were bitten by captive Saharan horned vipers, and the bites caused extreme swelling, blood clotting issues, and even kidney failure. The venom in these bites has special compounds that mess with blood clotting, attack kidneys, and can cause serious internal bleeding. The best treatment for these bites is specific antivenom, but it's clear that the bite of a Saharan horned viper is nothing to take lightly. Now here's another astonishing fact about this reptile. When it does move, the Saharan horned viper doesn't slither in the usual way. Instead, it uses a unique style called sidewinding. Picture the animal lifting a loop of its body, moving that loop forward, and then pulling the rest along behind. This sideways walking lets the snake move across the hot sand without letting its belly touch the ground for too long.
In a place as hot as the Sahara, this technique isn't just cool looking, it's essential for survival. While the Saharan horned viper is a champion of desert camouflage, it has some serious competition in the camouflage department. Around the world, there are other snakes that have protected the art of blending into their surroundings to catch prey and avoid being eaten themselves. Like the eastern brown snake, an Australian snake that is one of the most venomous in the world. Its brown color lets it blend in with rocks and soil, making it extremely hard to spot until you're practically on top of it. A bite from the snake can be fatal in less than an hour. Or the eastern copperhead, found in the forests of the U.S. This snake's pale tan and pinkish colors blend in perfectly with autumn leaves. It often freezes in place rather than slithering away, which leads to many accidental bites. Its venom usually isn't fatal, but it's painful, and since the reptile hides so well, encounters are common. The Perengaise adder, from Angola and Namibia, loves to hide in the sand like the Saharan horned viper. It mostly eats lizards, and its sandy-colored scales make it almost impossible to see. Thankfully, its bite isn't too dangerous for humans. Now look at this terrifying creature. It's the timber rattlesnake. This rattlesnake lives in the lush forests of the U.S. and uses its colors to blend into the forest floor. You might not see it, but if you hear its rattle, take a step back since its venom is potent. The Pacific gopher snake, found on the west coast of the U.S., can grow up to 7 feet long. The only plus in this situation is that this reptile is non-venomous. It camouflages well in forests and fields, but is harmless to people. Just don't scare it, or you'll get a bite, which is still unpleasant. In the rocky terrains of California and Oregon, you might meet the northern Pacific rattlesnake, which likes blending into dark brown and gold rocks. Hearing a rattle is often your only warning, since this dangerous snake is nearby. These neck snakes aren't particularly dangerous, but they're unsurpassed masters of camouflage. The smooth green snake has a bright green color that matches the leaves in trees and grass, which makes it practically invisible among foliage. The common European viper prefers hiding among leaves and shrubs, and the harmless common garter snake has colors that blend in with dirt and grass. Keep in mind, though, that even though all these snakes are not venomous, they can still give a painful nip. Oh, and I can't but mention the massive reticulated python. Even though it can grow over 21 feet, this South Asian snake is expert at hiding among leaves and shadows. It's one of the only snakes known to occasionally hunt humans, so tread carefully in its territory. Now, in the wild, snakes like the Saharan horned viper rely on camouflage to hunt and avoid being hunted. They might be blending into leaves, sand, or rocks, but in any case, these snakes have evolved to stay hidden from predators and prey alike. The desert viper buries itself to stay cool and catch food, while forest snakes blend in to hunt in silence or avoid curious humans. For them all, staying hidden isn't just a matter of survival, it's a huge advantage. So, next time you're out in nature, remember that you might be walking right past a hidden hunter, watching you from the shadows with a quiet, horrifying patience. Have fun out there.